So this is step 20. This is Jan'25 term. C. Who is one? Okay. What's the role of program counter in CPU? That's theory question. Again, to store the address of next instruction. And what's the correct order of memory level based on size? Register is very small. Then cache maybe in KBs. This is somewhat in KBs. Main memory is your RAM, so it can be in GBs now. And secondary, it is like 5.2 or like it can be in TBs. This is register is very very small. It stores only in bytes. Okay. In which of the following operators in C have right to left associativity? Okay. Assignment operator. This is from left to right. This is again from left to right. Same left to right. This first evaluates whatever on the right hand side, then assign it to the left hand side variable. ठीक है, then for which value of m0 and m1 the computation will enter into an infinite loop. ठीक है, let's simplify this. So r0 is storing something from m0 and then r1 is storing m1 and r2 is basically r1 minus r0. Okay, it's the difference. So if r2 is not equal to 0, then set or say r1 plus 2 करना है and go back to step 3. Mean here. ठीक है. So we can I like आप वो options या तो manually देखो किस उसके लिए जा रहा है or we can just simply plug in these values. So if we plug in 5 and 3, अगर 5 and 3 plug in होगा, so this will be your I mean 3, this is your 5. तो R2 में -2 आएगा. It's not 0, तो R1 को हम +2 करेंगे uh, which will be it will become 5. Then R2 will be 0, so it will stop here. So it's not the case. So probably like दोनों वैल्यूज में जो डिफरेंस होना चाहिए वो एक ऑड नंबर होना चाहिए, then it won't stop.
odd
तो
number
इसमें
difference 10 and 3 में है.
हाँ 3 में ही है,
ये
इस
8
केस
2
में
का
6 का
डिफरेंस 6 है,
वैल्यू.
7 6 का 4, उधर 2.
हाँ हाँ तो
कंप्यूटेशन नहीं डायरेक्शन है
हम्म
ये वाला.
इसमें 7 है तो ये आंसर हो गया. ओके. Now, what's the purpose of assembly this code snippet? ठीक है. R1 में 10 डाला, then R2 में 3, then there is a loop, ये some loop, इसमें R1 plus R2 and storing it in R1. This is a loop and R2 की value it's decremented -1. Compare R2 with 0. So let's see if we can say, okay, it means simplify this. Right. So if R2 is not 0, then we again do this thing. Okay, fine. So what it is doing, 10 and 3 आया, R2 is not 0, then R1 में वो R2 add किया, so R1 will become 10 plus 3 and 13. ठीक है. So this will become 13 and R2 2 हो गया. So this is 2 now. और नेक्स्ट स्टेप में वो आया तो 13+2 करेगा,
हर
फिर ये
हर
7
स्टेप
करेगा।
में बस ऐड हुए जा रहा है, मतलब वो
हाँ।
इटरेटिव वे में।
हर स्टेप में वो जो
मतलब
भी
पहले
वैल्यूज
बार
है
तीन
ऐड
ऐड
होगी।
होगा, फिर दो ऐड
हाँ
होगा,
फिर
फिर एक ऐड होगा, फिर तो जीरो ही
देन जीरो।
पहुंचेगा।
या तो
टर्मिनेटेड।
ठीक है, बाय सम ऑफ दिस थिंग। नॉर्मली भी देख सकते हैं ना, इसमें कहीं सिर्फ इंक्रीमेंट ही तो हो रहा है, डिवाइड और ये तो वैसे भी नहीं है। फाइन।
एग्जैक्टली।
ओके, नाउ व्हाट विल बी द आउटपुट ऑफ अवर प्रोग्राम? int main which case है a is 2, a यहाँ आएगा, a will go here, so it will print out this, say b की वैल्यू इनिशियली 0 थी, ये b की वैल्यू को 5 कर देगा, इन दिस 5। देन 3 वाला भी जाएगा, वो उसको 10 कर देगा। देन 4 वाला भी जाएगा, वो उसको 15 कर देगा। देन अ ब्रेक स्टेटमेंट, तो या 15 विल बी द आउटपुट।
ओके।
अगर अगर यहाँ हर कंडीशन पे नॉर्मली ब्रेक होता ना, तो वही ब्रेक हो जाता। अगर ब्रेक नहीं है तो वो सिक्वेंशियली चलता जाएगा।
हाँ, जस्ट लाइक वो बाकी सब में जो होता है।
हम्म ठीक है। व्हाट्स द पर्पस ऑफ दिस कोड? ओके, इट इज रनिंग फ्रॉम 1 to n, and it is checking if number is even, देन रिजल्ट में, देन जो रिजल्ट है उसका मल्टीप्लाई कर दो करंट नंबर से। तो कैलकुलेटिंग द प्रोडक्ट ऑफ,
मल्टीप्लिकेशन में तो अगर सिर्फ मल्टीप्लिकेशन देखें तो कैलकुलेट द प्रोडक्ट होगा, उसके बाद फिर ऑल
हम्म
इवन नंबर्स हो गए।
हाँ, तो कैलकुलेट द प्रोडक्ट में दो ये आ रहे हैं, और
यस।
दिस इज एडिंग ओनली इवन नंबर्स, या इवन नंबर्स, सिंपल। Good enough. Then how many times will the hello programming be printed? Okay, so print of hello programming. It will start at I is equal to 1. So I is 1, and it is less than 30. So I percent modulo 6 is again 1. So this condition fails here only, and it will check it, is it even? No. Then it will go again and again and again to basically, okay, for 1, I think this will get printed. For 1, this will get printed. Will get print. Then when it's a even number, it will continue directly. So nothing will get printed on the even side. Even are skipped directly until 30. So now what will satisfy this condition? What thing? So 45, I think this condition won't be satisfied by this number. Like,
What are the options?
what are the options? How many times? Yep.
Okay, if the options were like one or two times, we could have just calculated.
Yeah. Yeah. So basically, this number which is divisible by 6 and by 8 is 48. The minimum number is 48.
Yep.
So yeah. So this condition will, like, it can be ignored for this value 30. So if the number is odd, then it will print. If the number is even, it won't print. So 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19, 21, 23, 25, 27, and 29. That's
One, two, three,
all.
four, five, six, seven,
1,
eight,
2, 3,
nine,
4, 5,
10,
1, 2,
11, 12,
3, 4,
13,
5,
14, 15. 15.
15.
Wait, is 15 the answer?
It could
No.
be. 15 is not the answer, but we are also, like, not wrong anywhere. Maybe answer key.
Maybe.
Let me check C programming.
Won't it break at 24?
Huh? Okay.
24 पे break होगा ना?
हाँ
Okay.
yes yes 6 and 8 दोनों से
Sorry,
divisible है
sorry, sorry, sorry. Yeah, sorry.
and even I
हाँ, it got break at 24, तो 24 के बाद रन नहीं होगा, so it like these three values get cancelled out.
so 15 minus 3 is 12
Yeah,
Hmm.
fine. Convert the binary number to decimal equivalent 10, 10, 10, 10. This is 1, this is 2, this is 4, this is 8, 16, 32, 64, and 128. So 128 plus 32 plus 8 plus 2, this is 10, and this is
above as well 8
160.
and 2
Huh?
अच्छा कुछ नहीं
Hmm. So that's 170. So yeah, easy. Easy, easy. This is a hexadecimal representation, okay? So 7 into 16 to the power 4, 4, 3, 2, 1, sorry, into 3 plus A, B, C, D, E, F, 9, 10, 11, 12, 13, 14, 15. So your C is 12, 12 into 16 square, then 5 into 16 plus D is 13. Let me just calculate this. 16 into 16 into 16 into 7 is 28672 plus 123072 plus 80 plus 13. Let me add them all. 28762 plus 3072 plus 80 plus 13 is 31927 of Pagaturio. Basically, 287. Oh, sorry. 672. My bad. This is 31837. Yeah, correct. Then what's the output of this code? So 10 plus B is 20 multiplied by C, which is 30, divided by B. Okay, let's solve this. B multiply C divided by B minus A. So in this, firstly, this multiply will get resolved, like almost for similar priority, but firstly, this multiply got resolved. So this will be B into C. This is BC divided by B. So again, B got cancelled out. So this whole simplifies to C only. So A plus C minus A, which is again A and A got cancelled out. So this C. C is 30, so answer is 30. Which of the following is true for an 8-bit 2's complement? Okay, so 8-bit 2's complement is this thing.
this was discussed in the first week I think
Hmm.
like
Network teacher. Uh-huh. Yes, sir, please.
yes like this was just stated as a fact I think
Hmm. इसमें पॉजिटिव नंबर तक आई थिंक 127 जाता है देन इन
and negative
नेगेटिव
126 I think
128
oh sorry
देन
128 yeah
देन अ जीरो तो ये ओवरऑल 256 हो जाता है बट इफ समवन डोंट नो हाउ टू कैलकुलेट टूस कॉम्प्लीमेंट so just negate this number or say take complement of this number and add a plus one over here. So this will be your two's complement. Okay. So yeah, this is kind of a statement that you can have can store 256 first numbers by the 8 bit, and positive is this, negative is minus 128. Valid variable name. Name can start with underscore. Name cannot have this dash symbol. Name cannot start with this numeric thing. We cannot use already defined variables. And yeah, again, normal name. Now, what will be the value of M2 at the end of computation? So, R0 and R1 clear, and then R1 is equal to R1 is R0, or like M0 is 4, this is 4, this is 7. 7 minus 4 is 3. Now 0, 0 plus, this is again 7. Then R1 is R0. So R0 is 7. And then R1 is 3. So this is 4. Then M2 is 4. Yeah, just a minute. Okay, then find the minimum number of bits required to represent an instruction set where there are 16 unique instructions. Each instruction can at most have 3 operands. Find the minimum number of bits required to represent an instruction where there are 16 unique instructions. Okay, each instruction can have at most 3 operands. Fine. The first operand should be able to represent 32 registers. Second operand should be able to represent a single magnitude form, signed magnitude form. Sorry. Any idea?
I remember there was something like this, but the exact thing doesn't come to my mind right now. Let
Mhm.
me.
What's this thing? Three operands means A plus B minus C, something like this. Some operation and some operation. The first operand should be of represent 32 registers. It's a single flag. This one is 1 bit. This one is again. Hmm, this one's 3028. Oh wait, just a minute. In a single register, there are 8 bytes as sorry, 1 byte, or say 8 bit.
8-bit, 1 byte.
Nee, in one register we can say this is 32 into 8 bytes, or say bits to be precise. This is bits, and this is 1 bit. So yeah, this is 32 into 8, and for this we need 1, 2, 4, 8, and then 16, 32, and 1. So this is 64 and 1 sign bit. Oh, sorry. Yeah, this is the sign bit. So yeah, 1, 2, 3, 4, 5, 6, 7. 7 bit for this. 7 bit for this. 1 bit for this. Fill current. Hmm. No idea. Okay.
How is the answer 17?
No, completely blank.
We'll come back to this later, maybe.
Maybe possible. Tema, do you have any solution or something?
Not really.
Okay.
Trying to think. The first bit of it is the real challenge.
Okay. Let's see if this later on. So let's maybe try some
Hmm.
GPT or something. Okay. And what will be the output of this code? So z equal to z plus, and this whole thing x minus minus double equal to y and plus plus y double equal to z. So in this case, x will be passed on. So your x is, okay, let me write x, y, z. X is 5.
5, 6,
Okay.
and 7.
Hmm. So this will be z equal to z plus. Here your 5 will be passed on, double equal to 6, which is this, and then plus plus y. So means first the plus thing happens. This is 4 now. And this plus happens. So yeah, this is 7 now. So 7 double equal to 7. So this is false. So I think this will return 0 and this will return 1, but the whole things will become 0. So z equal to 7, which is again nothing got added to it. 7 plus 0 is 7 only. So in the end, I think the output is this 7 plus 7 plus 4. 4 14 नहीं, here made a mistake. Where's the mistake?
Where do you think the mistake is? Because I cannot spot anything.
Even I,
Same.
maybe the,
Seems
even
correct.
probably here only in the output, but again not sure of that. Let me just have a look. This will be 5 and this is 6, 7. This is 7, this is 0 and 1. No way, should be 18 only. Wait. Uh, One thing. In this AND operation, what a smart thing these like instruction or anywhere it does, वो पहले इसको सॉल्व करेगा. अगर ये ट्रू होता है देन वो इसको सॉल्व करता है, अदरवाइज वो इसको छोड़ देता है. So what we are doing a mistake here is, let me just delete all this.
So you're saying y won't get incremented.
Yes.
Okay.
So x is equal to 5, y equal to 6, and z is equal to 7. So z plus equal to, this will be again 0 as we all know. Now this, and after this won't get executed. In this it will become 4. So yeah, x plus y plus z is 4 plus 6 plus 7, which is 17. Oh, fine. Okay, done.
Okay, very
Let me
less
ask,
contents actually.
let me ask this question to GPT or somewhere.
For the questions which involve programming, you can
Mm-hmm.
maybe open up a code editor and simultaneously check as well. अगर कहीं पे doubt हो तो.
Ah, what you can.
Especially if the
But
code snippet is small.
yeah, For chat GPT, it is saying first operand is we have 16 unique registers, so it means 4 bits. Now bit for the first operands, it's taking log base 2 of something like these values 32, 16. So 32 is 5. So it's taking ये 5 bit का होगा it's saying, and 1 for sign bit and just for the magnitude. So इसमें बोल रहा है एक साइन बिट एंड ऑल्सो ये 7 बिट्स का होगा ये भी ऑल्सो कैलकुलेटेड एंड दिस इज 1 bit. Now 4 bit for the opcode, which is this. So 4 bits for this plus 5 bits for this plus 7 bits for this plus 1 bit for this sign thing, single flag. So this is 17.
Okay.
Hmm, ठीक है, fine. Let's remember this one now. यदि किसी और पेपर में मिलेगा तो सीट. ठीक है, then Feb is done. Let's go to October 2024. Select the statement. Wow, easy question. RAM is a volatile memory. ROM is faster than RAM. Never. Hard drives provide non-volatile storage. Correct. CPU cache is faster than main memory. Then registers are the fastest. We all discussed. Convert the following number into binary code. So yeah, for B A B C D E F 10, 11, 12, 13, 14, 15. So for B, it's 11, which is 8, 2 and this 1, 0, double 1. Only three options. One cancel out. Then for 5, it's 0, 1, 0, 1. So yeah, 0, 1, 0, 1. This will also get cancelled out. And then for E, it's 14, which is 8, 4, 2, and 0. Yeah, so 1, 1, 1, 0. And the last one is 9, which is 1001. So yeah, this one. Fine. If the output has only 5 lines, what will be the value of uh, input A? 5 lines. So means this run 5 times. For the first time, let's suppose value is 0 for now, or any like x. So it will scan or ask for x. Then this is x. So say A only. Then it will print A for the first time. Very first time it will print no matter what's the value. Then it will decrement the value of A. So A is now A minus 1. Or to be precise, but print thing happens in A minus 1. And it will check is it greater than minus 1. So yeah, it's greater than minus 1. Then it will go and print again in A minus 1 and print again A minus 1, print again A minus 1. So 1, 2, 3, 4, and print again. Now this time condition fails. So 1, 2, 3, 4. So we just did A minus 4. It should be greater than -1. If we even choose 4 as the main value, as the a is equal to 4, then 0 is greater than -1. So yeah, easy. Then if m m0 and m1 are the input, so then m2 is the output. What will be the value of input in below two cases? Okay, so m1 is 7 for the first case and 3. Now this is 3 minus, this is -4. Now if R0 is 7 is less than -4, so it's not. Then go to step 5, which basically R to the value -4 is equal to adding those initial values. So 7 plus 3 is 10. So R2 is now 10. We will give output as R2 plus 10. For the first case, it's 10. Two options. Then for the second case, this is 2, this is 5, this is 3. So if R naught in 2 is less than 5, which is yes, then we'll go to step 6 directly. So R2 is 3. Yeah, R2 is 3. This is 7th long. Good to go. Find the hexadecimal representation of the word cat in ASCII. Okay, okay, they given us a hint. So C is 67, A is 65, T is
I'll suggest that we first calculate the first two.
okay. Let's but it's 84. Yeah, but yeah. 67 is now let's represent the hexadecimal thing of that. So 67 and hexadecimal is 16. Calculating this. Only it's 4 times. Oh, 4 times. I think some no. Wait. Someone remember this thing? I again forgot how to do this.
Conversion to hexadecimal, right?
The hexa to yeah. Sorry. Yeah, norm conversion to hexa. So 10 to 16.
That is what I was wondering.
Hmm. Wait, just binary to hexa. Does anyone remember even conversion of decimal to binary? That's also
Darn it, I forgot. Let me see, I might have it.
not stripped out. Okay, so maybe let me just try this. This is 48, not 48. This is 4 times basically. Yep. And the remainder is 67 minus 48 is 19. So why? Wait,
43, right?
uh, wait. 16 into 4 is 64. My bad. 16 into 4 is equal to 64. My math got bad for. So this is 4 and the remainder is 3 in this case. Yeah. So that's this is your I think way to do this. Oh, there's some way about. Now we have to see this hexadecimal conversion. Wow. Okay, I'll see this later. See this later. Just
You
for
have to do it this way only. Keep dividing by 16 till your quotient is 0.
yeah, so like this is fine. This is 67. This is 16. This is 4. And this the remainder is 3. Now there is something like arrow in which we take this.
Actually,
This only
43 should be the hexadecimal representation if
yeah,
I remember
it
right.
is, it is. I think even
So,
this side from we start from this side and we'll take the remainders only.
yes, so 0x43, like,
Okay.
what is the
For
confusion?
for confusion. Okay. Fine.
Like, the first of the three is
Mm-hmm.
0x43.
Okay. So this is 0x43.
Yes,
Now let's
next would
go
be
with
0x41 then, because 65 is just 2 less than 67.
yes. 43,
Yeah, so you
41
And when
will
you
be
have 43 and 41, there is no other option that is 43 and 41. So you don't really need the third one.
yeah.
Otherwise, you can calculate if you want to do it for the sake of
If
completeness.
if we even do this, then this will be 5 and this is 4. So yeah, 54.
Done.
Which of the following represent the order in which this will get executed? So 8 minus 2 multiply 3 plus 4 by 2 multiply and divide have the highest priority. So this or even that it is the BODMAS follows here. It is so divide, multiply, and addition subtraction. Then what will be the output of this program? So carry is equal to 3, B is equal to B, which is 66, A 3, which is some variable, and C is F, which is, oh wait, these are small. So this is your 98.
98.
Yeah, so B, C, B, C, F. 98, 99. So this is 102, 102. And then if we do D, 65 plus C is 102 minus B is 98 plus A, which is 3. So this is 65 minus 102 plus, oh, 65 plus 102 minus 98 plus 3, which is 72. 72 is B, C, D, E, F, G, or okay, this is 66, 67, 68, 69, 70, 71, 72 is H. Okay. What will be the output of this program? So Z double equal to X minus minus. So X is 2, Y is 1. X minus minus is 2, but this will be 1. Double equal to 1. This is false. Then, so it will check the OR condition. Oh, but it will check the other condition,
Y
logical.
becomes 2, right?
Now this in this case, y becomes 2. 2 double
So 2
equal to
into
2
2,
is true.
so
Mm.
plus y again. So it becomes 3, and 3 is equal to 3.
And then
3 is equal to
becomes
3.
it becomes yeah 3. 3 double equal to 3. Yeah, so this is an like z will be equal to 1. So x is 1, y is 3, z is 1. Yep. We're just taking the precedence of these logical operators. Does anyone remember? I think.
I don't, but I can simply check it out.
Hmm. I think the and has highest, then the or, and then yeah, these both are both above them, then bitwise and all. So yeah, not is also above there. Okay, fine. What will be the output of the above program? Okay, so A is 1. This is 6 by 3 double equal to 1, which is not. So this will be cancelled out. And B minus C, which is 6 minus 3 is greater than 3. It's again not. Then B is greater than A. So 6 is greater than 1. Yes. Or. Again, yes. So yeah, why not we care? It will print out C. Find the minimum number of bits required to represent an instruction where there are 16 unique instructions. Each instruction can have at most two operands. Assume that first operand is 32 registers and second is this. So this we know this is 7 bits. This we know this is 32. So log 232 is 2 to the power 2, 4, 6.
Five, I
So 2
think
by
you
8,
said.
yeah, 5 bits. And this is 4 bits. So yeah, 7 plus 5 plus 4. This is 12 plus 14 is 16. Fine. What will be the number of lines printed by the above program? 0, 1. Okay. So if the number becomes greater than 8 or equal to 8, it won't print anything. So
Same
there's
for
this.
if it is divisible by 4, which is only 4.
Sorry, you can just. Yeah, Ignesh, can you please repeat?
4,
Yeah, 4 is
obviously.
4 cancelled out, 0 will cancel out. These all, now these are there. So if the number becomes divisible by is greater than 6, which is again 7 afterwards, so we again don't care about those numbers.
Greater
Oh,
than
wait,
6
wait.
and
Yeah,
divisible by 3.
by 3. So this is 8 also
So
comes in and 9. So 9 is greater than 6 and divisible by 3. So here no breaks. And this also get cancelled because of this I percentage 4. Yeah, these 6 times only. First, second, third. Yeah. So this is 4, this is 3, this will be 7. R1 is 6. Oh, sorry, 8. Then R naught is equal to R2. R2 is 7 minus this 8, which is minus 1. So your output will be minus 1. What's the minimum number of bits needed to represent using sign magnitude? So 1 for sign, then we need 7. So 1, 1, 1. They are 4 bits. Consider the following C snippet. What will be the value, final value of C? A is equal to 1, B is equal to 2, C double equal to A plus plus, which is 1. This will be 2,
plus 3.
3. This is also 3. So C is 4. Now C is equal to C multiplied by A plus B. A plus B is 5 and is 20. Yeah. What will be the maximum possible value for the input variable A? That process, this will output okay. The number should be less than 4. Okay, so number can be 3 or somewhere 2, 1 or somewhere here. And it should be divisible by 3. 3 or 0.
3 is the maximum possible. Okay. A should be divisible by 3 and A should be less than 4.
Wait. There's a catch. There's a catch I haven't seen. Like A% is 3. If this is 3, then this will return out 0. So this end will fail. So we need uh, any value lesser than 3, or maybe because we don't have any upper criteria. So we can take 2. 2% is 3 will return out 2, which is again a true condition. So yeah, 2. Yeah, 2 is the maximum possible value because that satisfy it's less than 4 and satisfy this condition too.
So for percentage, that is just whatever. If there is a remainder, then it will return true, right?
Yeah, if there is any if condition, now if this is 0, then it will say this is false and it
And
don't go
if it is
there.
any positive value, it will say
No,
true.
even positive or negative, it doesn't bother about that.
Anything other than
Anything,
0.
yeah, anything other than 0, then this will follow if condition.
Great then.
Consider the C program given below. Okay, everything is 4A is equal to B is equal to C is equal to 4, 4, 4. Now, wow, whatever maths they can do, they did. C minus C is
Someone
decremented
teach
here.
them clean coding.
C is 3 here. Now B plus equal to 3. So this is 7. So this passed out with 7 and A multiplied by 7. So such a good time. This is 28. 28, 38. Yeah. A plus B plus C, 38. Consider the again following what will be the output of this. A is 0. Wait. Okay. I I is 1 for the first time. J is also 1. J is less than I? No, so nothing will happen. Then I will become 2. J will be 1. So J is less than, yeah, 1 is less than this. So it will take A plus equal to I, which is A is initially 0 and I is 1. It will add a 1 here. Then this will be
It will
this
add
will
2,
become
right?
right. Wait. Okay.
It is adding I, not J.
It's
Yeah.
adding I, so it'll add 2. A will be 2.
Okay. Okay. Yeah. Then for the third time it will become 3. Then this 1 will be executed, so it will add 3. Then 2 will be executed, it will add 3. Then it fails. Then 4. So for 1, 2, 3, it adds the 3 times 4, 4. It's 12 basically. Then for the fifth thing, it will add 20. And yeah, that's all. So 20, this is 32. This is 6 and 8. 8, so 40. Output of a program. A is less than 15. Okay. We need while condition. B is 7, C is 0. Then A plus plus 1 is less than. This will be 2. If A is less than B, yes, continue. Then we'll go again. Then this will be 2 is less than 15. Yes, then it will be 3. Let's go until 6. Yeah, 6 is less than 7. Yes, 6 is less than 7. So continue. Now it will become 7. So wait. Now this will become 7. Now this condition will fail. So it will add a C here. Now for every iteration it runs, it will add. So 7, 8, 9, 10, 11, 12, 13, 14. These many values. This is 1, 2, 3, 4, 5, 6, 7, 8. Why?
But C should also change, right? It is also inside the while loop.
C is changing, na? Like, so for the first time, C changes at here. C becomes 1, now 2, the 3, 4, 5, 6, 7, 8. Now I think, wow, I think we'll have to do this whole thing, then only. Fine. So once A becomes 7, this loop won't matter, this thing. So this is 7 now, and this will increment the C by 1. Now this will go as this. In 7, it checks. Okay, 7 is less than this. Now this will add 8. This is 8, and it will make it 2. Now 8 will go here. This will be 9. This will be 3. 3. Now 9 will go here. And this will be 10, and this will be 4. 10, 4, 11, 5, 12, 6, 13, 7, 14, 8. Oh, yeah, 14, 8. Now the 14 will go here. It will say, yeah, it's greater than. Then it will say, then it will make it 15, 15, and then it will add again 1. So, yeah, 9. Fine. And this paper is also done. Wow.
Yep, we did two papers within an hour. You did it
That's,
mostly.
no, oh, we did it. Okay. Then, then which paper? May term. May term is not there. This one, right? July 1. Download.
Or do you want to join the live session of C that is happening right now?
Say I am ready with anything. Let me just stop the recording and I'll record it again. Okay, stop now.